This lesson is on the sum of a geometric progression. First of all, let's see the notation. Just like for arithmetic progression, Sn denotes the sum of the first n terms. So if we have S25, this means the sum of the first 25 terms. Let's now consider a geometric progression having n terms with first term A and common ratio R. If we are considering the sum of the first n terms, it will be as follows. A plus AR plus AR square up to the nth term. The formula is AR power n minus 1. So we have to add all these terms to obtain Sn, the sum of the first n terms. And the formula for Sn is A into 1 minus R power n, the whole over 1 minus R. And here R cannot be equal to 1. It is undefined for R is equal to 1. And if you remember, R can be both positive or negative. And some people prefer to use this alternative form of the formula when R is greater than 1, just to avoid obtaining negative values in the numerators or denominators. So the alternative form is Sn is equal to A R power n minus 1 over R minus 1. So here undefined for R is equal to 1. Let's have a look at the first example. Find the sum of the first 12 terms of the geometric series 3 plus 6 plus 12 plus 24. So here we have first term A 3 and the common ratio is 2. Each time we are multiplying the term by 2. And we have to find the sum of the first 12 terms, that is S12. So here R is equal to 2. R is greater than 1. So it is easier to use this formula, the second one. So we have 3 into 2 power 12 minus 1 over 2 minus 1. And the answer is 12,285. We can use the first formula. We would have obtained the same answer. So the first formula using 1, let's call this 1 and this one 2. So using 1, S12 would be 3, 1 minus 2 power 12 over 1 minus 2. So here in the denominator, we would have obtained a negative answer. And here also in the numerator, this would have been negative. So just to avoid negative fraction, we prefer to use the first formula here. So this again gives the same answer. So we can use any of these two formulas. Now we have a second example. The third term of a geometric progression is 9 times the first term. The sum of the first 6 terms is k times the sum of the first 2 terms. Find the value of k. So here, the third term of a geometric progression, that is u3, is 9 times the first term. So we obtain this equation, u3 is equal to 9a. And u3, the third term, is ar square. So this is a first equation. From this, we obtain 9a divided by a. R square is equal to 9. So r, we take square root of 9. We obtain plus or minus 3. So both answers are correct because the common ratio can be positive or negative. The sum of the first 6 terms is k times the sum of the first 2 terms. Now we are talking about the sum. Sum of first 6 terms, that is S6, is k times the sum of the first 2 terms is k times sum of first 2 terms, that is S2. So here S6 is a r power 6 minus 1 over r minus 1. This is equal to S2. Sum of first 2 terms, it is a r square minus 1 over r minus 1. Or we can use the alternative form, that is 1 minus r power 6 over 1 minus r. Here also 1 minus r square over 1 minus r. We will obtain the same answer. So here we can divide by a over r minus 1. We obtain r power 6 minus 1 is equal to k into r square minus 1. And k is r power 6 minus 1 over r square minus 1. So now when r is equal to 3, we obtain k as 3 power 6 minus 1 over 3 square minus 1. This is 91. So k is equal to 91, and when r is equal to minus 3, k is equal to minus 3 power 6 minus 1 minus 3 to the square minus 1. Again, we obtain k as 91. Hence, k is equal to 91.